and welcome to this video. In this video we are going to be moving on to part 2 of evaluating a machine learning model. So we're going to be learning another way to evaluate a machine learning model so that we know all the different ways. So let's actually start. So this is where we left off last time, and here we learnt how to evaluate a machine learning model with the simple score method, and this was pretty easy to understand. So now we're going to go on to learning about the scoring parameter. So we have not met this before, so today is going to be a very interesting lecture. So in Markdown right here, I'm just going to write 4.2 evaluating with the scoring parameter. Okay, so we'll be looking at this, but we'll also be this scoring parameter comes in with a method, and this method is called Crossfire Score. Now this is quite a complex method to understand, but we'll understand it today. So first obviously we will have to we're going to want to do it with a classification model. So I'm going to just copy the code we did last time. So this is how we made our classification model, and we'll paste it here. But now at the top, what I'm going to do is I'm going to write from Scikit-Learn dot model selection. So from Scikit-Learn dot model selection, import cross-val score. Okay? So the first thing we're going to want to do is first obviously we want to run this, and then next what we want to do is first we're going to compare the score method we looked at last time to Crossfire Score and what they both how they both differentiate. So we're going to go clf.score. We're going to pass in x-test and y-test. So this is the typical way you would get it when you're using clf.score. So our score is about 0.9, I'd say, if I rounded it. So now we're going to look at Crossfire Score. So we're going to go Crossfire Score, and so the first parameter is CLF. Actually, what we'll do is we'll press Shift Tab. So here we need to put in the estimator. So ours is CLF. Then you put in the X data and Y data. That is actually set to a default of none, but we're going to put it in anyway. And if you scroll down, you can see there's a scoring parameter. So we're not going to look at that right now, but we're going to look at that actually later. But yeah, so what I'm going to do is I'm going to pass in my estimator, which is CLF, our classification model. And then I'm going to put in X and Y. And then if you run this, see what happens. So it might take a bit. So here we've got in 5 different lists, 5 different sort of values. So what could this mean? So this is actually can be quite confusing. It's Crossfire Score, but that doesn't relate to these 5 lists. So let me show you another explanation that we could actually use. So Crossfire Score stands for cross-validation, and basically so first if we try to compare the score method to cross-validation, so score method we'd obviously just normally say clf.score, x-test and y-test. So imagine we have 100 patient records. So what the score method does is, so since we split it into X and Y, what it does is it basically just has 20% test data. So that is our Y data. So that's our test data and that's our training data. So it tries on one bit and then it'll just get a specific score. So for cross validations, it's a little bit different. So we go Crossfire Score, CLF, X and Y. So we have to pass in X and Y, not only the test ones. So again, we have 100 patient records, but this time we have a lot of boxes here. So we've got our 20% test data and 80% training data, and then this blue bit on the next row represents test data, and so this represents training data, and this represents test data. So what cross-validation does is it tests on every single bit of the data, and so that's what each list is. So each list shows how well it has done on each part of the data. Okay, so that's what it shows, and this is actually quite better because it will allow you to actually know which part of the data the model is not sure on and which parts it is amazing at. While CLF.score isn't while CLF.score, what it does is basically it only tests on one bit of data, and you don't know if it actually got that good score that you've been hoping for by luck or not. So basically, this one could be by luck, but here you'll be able to see which ones have better scores and not. So back to our Jupyter notebook. So back to our Jupyter notebook. So now there is one more thing I would like to show you. So basically, we're gonna go. Basically, Crossfire Score. It actually contains another parameter. So if we just pass in CLF, X and Y, it contains another parameter, and that parameter is called CV. So how many cross validations you want in with your data. So cross validations is equal to 5 as a default. So that's why we've got 5 different lists, because it tested on 5 different parts of the data. But if you put CV is equal to 10, what it will do is it will give you 10 different lists. So we'll just wait for this to run. So there we go. We've gotten 10 different lists. So now you will get a few more higher scores because there's more bits. You can also put 100, but I'm not going to do that, otherwise it's going to take a very long time. So you might be thinking, why are we learning this? All we're supposed to be learning about is the scoring parameter. Well, as you saw before, the scoring parameter is here. So now, as a default, it's set to none, and that allows it to sort of score. So when scoring is set to none, that actually allows it to score on all the data. So basically, we're going to just create it. I'm just going to say np.random.seed. So what we're going to do now is we're just going to compare them again. So 42 as always. So here we're going to put our single, training and test split score. So this is just only on one part of the data. So obviously we'd be using, so I'm going to create a variable called CLF single score, and so we're going to say is equal to CLF.score, and then I'm going to pass in X test and Y test. So now that we have made that variable, we're just going to create another variable underneath. So what we're going to do now is we're going to actually take the mean of 5-fold. So CV can also represent folds, so like the different parts of the data, they can be known as folds as well. So take the mean of 5-fold cross validation score. So we're going to go CLF cross val score, so this is a variable, is equal to np dot mean, and then I'm going to put in cross val score, and again we're going to pass in CLF, x and y. And after that, now we're just going to sort of compare the two. So I'm just going to write here, compare them. So I'm going to go CLF dot single score. So, oops, not CLF dot single. CLF single score. And then we're also going to want to put in CLF cross val score, and now we can view them both. So basically they both got around the same, but basically this one's actually a bit lower now, but this one you can actually think of the cross val score as a bit more trustable than the normal score method, because remember, cross val score goes through all of the data. So now we're just going to talk about the scoring parameter. So basically, the default scoring parameter of the classifier, so of the classifier itself, is equal to mean accuracy. So you might have heard this. If we go to our classifier right now, so clf.score, so shift tab, return the mean accuracy on the given test data and labels. So that's what it basically does. The default scoring parameter of the classifier is mean accuracy. So that is why we didn't need to put in, that's why scoring is set to none, because it'll just use the model's default scoring parameter instead. Unless you want it to use a different one, it doesn't really matter about the scoring parameter. So we're going to go clf.score just to see, and we need to pass in x test and y test. And again, we just shift tab, so return the mean accuracy. So that's actually quite an important thing to remember, that the default scoring parameter of our classifier is mean accuracy. So I'm just going to put another comment here saying scoring parameter set to none, set to none by default. Okay, so it's going to be set to none by default. And just to view this again, we're going to say cross val score, and we're going to pass in CLF, X and Y, and then scoring is equal to none. And if we run it, it's obviously going to have no effect on the result. But just basically, the reason it's saying scoring is equal to none by default is because all it's going to do is it's going to use the classifier's default scoring parameter. Unless you want it to use something else, you can leave that scoring parameter alone. So yeah, this is the end of the video. In the next video, we're going to be looking at, doing this with a regression model, or we'll be looking at the next one, which is problem-specific metric functions. So if you like this video, please like and subscribe. That would really help. If you have any doubts, please comment them in the comment section below. And thanks for watching this video as always. And yeah, I guess that's it. Bye.